All right, let's discuss weight and balance issues for drones. We do have two different kinds, basic kinds of drones. We've got the multicopter, which we're familiar with, and fixed wing drones, but both of them are affected by weight and balance. Uh, there's two different things. Weight, there's a maximum weight that a drone will carry, and then there's um, balance. Typically, multicopter center of gravity is in the middle of it. That's the way it's designed. But still, you might have additional equipment attached to it that might affect the balance. But anyway, backing up a little bit, there are, we've talked about this already, but four forces of flight, right? We have the lift opposing the weight and drag opposing thrust. So there's lift, weight, thrust, and drag. Maintaining proper weight and balance is critical to aircraft stability as well as its ability to fly properly. So weight, of course, is just it's a gravitational force that pulls down to the center of the Earth, right? We call them G factors, basically. Same thing, gravitational force. Well, for any planet, for that matter. The drone that we sent to fly around Mars had the same issue. It's opposed. It's of course G factors or gravitational force is opposed by lift. If the weight exceeds lift, the airplane can't maintain altitude, of course, or maybe even leave the ground. So, okay. Okay, here's an example of the issue of weight, right? Overloading a UAV can put stress, graphically displayed here in the picture, but it can put stress on its ability to maintain this lift. Overloaded UAVs can be stressed beyond their operational limits, causing structural damage, but definitely less maneuverable and a reduction of excess power available. So just consider that. All right. Pretend like this is a fixed wing UAV, right? Center of gravity has a range. Lift is, of course, perpendicular to the wing up, but we have different aerodynamical surfaces in order to create stability, but most fixed wing drones will have a range of center of gravity where it's okay to be out of the exact center, and that's okay. But forward CG and aft CG, that's forward being the front of the nose and aft being towards the tail, definitely can affect the characteristics of manned aircraft as well as drones. Um, Aircraft that has forward CG will tend to pitch down, and aircraft with aft CG will tend to pitch up. But again, it's just recall that center of gravity is a point in which all the weight of the aircraft is considered to be concentrated. And it may shift to a certain degree, but it is careful not to go beyond limits. And of course, weight is the other issue as well. Aircraft with forward CG tends to pitch down, aircraft with aft CG will tend to pitch up. Properly balanced CG is important for stable and predictable control responses. Okay, companies provide manned aircraft with specific maximum gross weights for their product, as well as a range of balance. Most production drones we have now have none of this information. They're, by the way, the manufacturer of aircraft are required by the Federal Aviation Administration to have these to publish these limits so that we can be safe. But for drones so far, we do not have many of these calculated ranges and maximum weight. So we're a little bit of an experimental process at this point until the FAA starts certifying drones. But anyway, it all depend on the model of the aircraft, strength of the structure, right? The ability to provide enough thrust, enough lift, as well as battery power and wing loading capacity. We think of these little drones, right? But you have to think this is a course on commercial drone operations. We're moving towards larger and larger drones. So We have to think big. Even though we're operating with small aircraft, we have to think big. We see that we know it's either going to fly or it's not going to fly, right? But for the future, we have to consider the fact there will be larger drones. So the maximum gross weight depends on some various factors, including the strength of the actual structure, the amount of power available, either battery or maybe some other chemical process like gasoline or diesel or hydrogen. Wing loading, propeller loading capacity. Okay. So overloading a UAV will limit its capability, of course. It's going to take more battery power to make an operation, right? The motors are going to have to turn faster and longer to maintain flight. It can add stress to the parts, can reduce its performance. At some point, it will reduce its ability to operate, and shortens the lifespan of the aircraft. Right, the motors filling at 100% tend to wear out quicker than batteries that are running at 80%, which is what you're really shooting for. Also, note this also that it increases the angle of attack of the propeller blades, or if it's a fixed wing drone, the wings, and which will indeed increase the stall speed. Stall speed is when the air is no longer, we talked about that in aerodynamics, but no longer smoothly flows over the airfoil, whether it's propeller blade or the wing. It no longer flows smoothly over the wings. Okay. And extra weight to a UV also requires additional lift, whether the propeller blades or whether it's just angle of attack for the wings. And then we have other things that happen even when we have increased the amount of weight, or if the balance is not correct, then there's environmental conditions that decrease performance as well. Strong winds, high elevation, that relates to the thinness of the air. The higher we go, the thinner the air is. High or low air temperature, right? The hotter the air is, the further apart the molecules are vibrating, and the air is thinner because it's hotter. Or humidity does the same thing. Humidity moves the molecules a little bit further apart, so humid air is less thin. The point here, of course, that the UAV operator may need to reduce the weight of the drone to compensate for unfavorable conditions. So on top of the baseline, then we may have, let's say the drone could carry 20 pounds. We know it can carry 20 pounds, but the weather was not optimal. Either there was higher elevation or warmer temperature. We might not be able to carry 20 pounds of payload. Okay, 3 axes, you just need to be sort of familiar with this. There's 3 different axes. We've talked about that also. This is sort of a review of aerodynamics, but there's pitch, nose up or down, yawing left or right, and roll describes whether the UAV rotates clockwise or counterclockwise. So just be aware of that. Not a big deal. Okay, again, reminder, lift keeps the UAVs in the air. So consider this picture here. With him swinging on these cords, well, is this a UAV? It all depends on whether or not this person is a passenger with no ability to control the drone. Is somebody else flying this from the ground, in other words, and he's just riding along? Or does he actually have control? If he has control, it's not a UAV. It's some kind of aircraft. But if it is a UAV, is it within its flight envelope? It would be hard to believe because he's pretty heavy and it may spin around there. We really don't know because it's, again, an experimental aircraft. But it's possible that him swinging back and forth, and we'll demonstrate that at a later lesson. We'll go outside with a drone and pick up a jug of water and on a cord, and we'll see how it really does seriously affect the aerodynamics. Again, just a review again, forward or aft CG. CG can change due to weight or external conditions. Here's a drone that's turning, a picture here of a drone that's in a turn, or maybe compensated for the wind. Now the center of gravity, because that big old camera is off to the side, the center of gravity has changed. Center of gravity operates perpendicular to the earth, right? Straight down. So now the weight is off to the side, it's affecting it. Forward and aft CG, that's sort of, for a multicopter, that's vague because it may be flying sideways, but anyway, just bear with me here. Forward CG tends to cause a multicopter to drift forward, or an aft CG would tend to drift backwards. All right, additional weight can make a UAV unstable. It's basically unstable to start with. That's why the electronics are super important, but it may become more unstable if it gets too heavy. And may result in the loss of control, certainly. But anyway, just recall that, just remember, since there's no numbers right now, additional weight can create unsafe flying conditions. If we have numbers, when the FAA requires the manufacturer to provide those numbers, there will be a manual or of some sort the manufacturer produces that pilots look at and go, here's how much weight I can carry. And we need to abide by that. By overweighing or creating or putting more cargo on there than is authorized would definitely make an unsafe aircraft. And of course, don't forget the external factors. Weather, wind, payload can shift a UAV. Again, manufacturers provide little or no information on that at this point, but eventually UAVs will be marked where the actual center of gravity is located, so that if you were to add some kind of aftermarket alteration, you would know this is where you need to place that unit, additional unit, so that the center of gravity might remain in its proper position. At any rate, until then, we don't want to assume that an altered UAV will fly in the proper way. We need to be very cautious to start. Okay, now we have home-built aircraft. Use it from scratch. You can put parts together and make one. It's not that big a deal. It's just about as expensive as buying a drone, though. I've done the research. So how do you determine where the center of gravity is? You have to do some kind of hang it on a string or something like that, so you can tell, exactly where the center of gravity is. It's like balancing. Well, it's like basketball players balancing the basketball on their finger, right? That's the center of gravity. Of course, it's a sphere. Not that hard to find. You got to spin it, gyroscopic forces. I understand all that, but still, that's basically how we're going to find out where the center of gravity is. Okay, load factors is another whole other factor that is related to the center of gravity and G units. G unit, remember that's gravitational forces. Load factor is the weight that a UAV wings or propellers support during level flight. Load factor is 1 G when we're just flying in level flight. But as we turn, because of centrifugal force, these G factors are increased. And you may have, if you've been in an airplane and been in a turn, you notice that feeling in the stomach as the aircraft, you increase the G factors in a turn. The same with a drone. So if you're at maximum weight, on your own experiment, in other words, you take a weight, pick it up, it flies. Once you start doing turns, that effectual weight is going to increase. The weight doesn't increase, but the G factors make it way more than it is. And it may exceed the ability of the aircraft to fly. The FAA wants us to look at this chart and be able to interpret it. And we'll go through that in class. It's not something that you can look at it. It's not that complicated. There's a right-hand side and a left-hand side. I would just urge you just to look at the left-hand side and don't worry about the chart. But it's probably something you need to look at. The load factor chart helps us to calculate how much a load factor increases as bank angle increases. So again, it's like on a 60-degree bank turn, there's 2 G's. So something that weighs 10 pounds, it will feel from the drone will feel like it's carrying in a 60-degree bank turn. It'll feel like it's holding 20 pounds, 2 times whatever the weight is. Oh, there's an example. 25-pound UAV enters 60-degree bank angle, has a load factor that has 2 times, that's supposed to be times, greater than normal. So 25 times 2, 50 pounds. That's pretty significant. All right. If the critical angle of attack is exceeded, that is, again, because of the increased weight, critical angle of attack may be exceeded. Aircraft may stall, and we have a video on this same module about stalls. But, or no, that's an earlier video. about stall. So stall doesn't mean anything about the engine quitting. It just means that the airfoil is no longer, the air is no longer flowing smoothly over the airfoil, whether it's a wing or propeller blade, and the aircraft will not have enough lift and it will fall from the sky, just like an airplane. And again, just to remind you, repeated overloads can cause components to fail. Thank you.